Assalamualaikum and good day everyone. So today we are going to continue with the next chapter, chapter 8, which is differentiation. Okay, so for this chapter, we have several subtopic, which is about four. And the first one is derivative of a function. So we are learning about what the meanings of differentiation. Okay, so it's a derivative. Come from derivative will be differentiation. Okay, so for the first lecture out of 5 lecture for this chapter, at the end of the lesson, students should be able to determine the derivative of a function using the first principle. Okay, so we have the formula for the first principle. So this formula is using the concept of limit. Okay, so that's why chapter 7 is important for you guys to understand. Okay, it's about the differentiation itself. Okay, now derivative of a function 8.1. Suppose that we wish to find the gradient of a curve y equal to fx at the point of p of xy on the curve. So at a certain point xy for this certain function. Okay, so we have a graph here. We can see the graph, the curve fx here, and then the point xy is here. Okay, we want to find the gradient of the curve. So the gradient of the curve at this certain point is actually defined on the graph. Okay, it can be found out by finding the gradient of the ratio between the Qn and Pn. What is this? It's actually the difference between point Q and P, right? So this is a distance between y coordinate of Q and P, right? Which is y, let's say Q is x2, y2, P is x1, y1. So usually it's a y2, difference between y2 minus y1 divided by x2 minus x1. This is what we learn in high school using the ratio between difference in y and difference in x. But for this topic, okay, so we have fx on the point P itself. Okay, but at point Q is a point on that same curve. Okay, point Q, if we have a difference of x by h, so point Q will have x plus h as the x coordinate, and the point y is equal to f of x plus h. The same as P, we have x and fx, where this is equal to y lah. So the ratio between Qn, which is this is the difference between the y coordinate, and the Pn, which is the x coordinate, is equivalent to the y here, which is f of x plus h, minus the y on P, which is fx, divided by Pn, the x coordinate of Q and P. So it will be x plus h minus x. Okay, so what is this? So for the denominator, we can simplify it as h. Why? X minus x will be cancelled out. We left by h. So this is the gradient. Okay, so what is the why is this connected to the limit? Okay, so let's see. If we move Q nearer to P, say to Q1, Q2, and so on, so the gradient of P1, PQ will give better approximation for the gradient of tangent. Okay, so it will be this here, 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 here. So the gradient is getting better, right? So the gradient of the curve y equal to fx at point xy is given by limit of f of x plus h minus fx divided by h as h approach to 0. Why? The difference between p and q is getting smaller. The q is nearer to p. So the distance between p and q is getting smaller. That's why we want the distance. Here is the distance between x coordinate of p and q. This h here, we want it to be smaller. That's why we want to try to find the limit as h approach to 0. Okay. Derivative of a function f with respect to x is denoted by f prime x. Okay, so this is the representation of derivative of a function f prime x. We have prime here. Okay, and defined as f prime x of x is equal to limit of f of x plus h minus with f of x divided by h as h approach to 0 when the limit is exists. If the limit exists, function f is said to be differentiable with respect to x. So how do we know that the limit exists? Means that we have the limit from the right side and the limit from the left side and it's equal to, right? So the process of finding the differential coefficient of the function is called differentiation. Okay? Okay. The notation that is sometimes used. So other than f prime x, we also can use the y prime. Okay, it's the same as f prime. This is y prime. Or you can say it's derivative of y with respect to x. dy dx or derivative of fx respect to x. Okay, so we have four methods to write. First, second, third, fourth. Okay. For example, the derivative of y equal to x cubed can be written as derivative of y, which is we can replace it as x cubed or just dy dx. F prime x is equal to the limit of f of x plus h minus fx divided by h as h approach to 0 and is also known as the first principle. So usually if they ask you find the derivative of that by using the first principle, then you have to use this formula, no other formula. So you have to use this formula. Okay, now let's do some example. Differentiate each of the following using the first principle. Okay, we have A and B. So by using the first principle, what we need to do, we just substitute into the formula of first derivative. So what is the formula? It's limit of fx plus h minus fx over h as h approach to 0. So we have fx. So we have this part. We don't have f of x plus h. So what we need to do? First, find what is f of x plus h. So this is the first step you need to do. Okay, so we replace the x on the left side and the right side with x plus h. So what we have? So it will be 3 multiplied by not x but x plus h and then plus with 2. So what do we have here? It's actually 3x plus 3h plus 2. Okay? And now just replace it into the formula. So f prime x is equal to limit of f of x plus h, which is 3x plus 3h plus 2. And then minus with fx. What is fx? Fx is equal to 3x plus 2. After that is actually, if we follow the formula closely, it will be 3x plus 3h plus 2, and then minus with 3x plus 2, limit divided by h equals to 0. And then what we have here, negative, because we expand already. Okay, that's why we have this form. Right? So the answer 3x plus h plus 2 minus with 3x minus 2 over h. Okay? Let me highlight here. Okay, minus 3x plus 2. fx plus h. And then after that, what you need to do? Just simplify the top one. So what do we have? The top one, 3x. Boleh subtract the 3x minus 3x, right? Okay, let me change. Yes, blue. So 3x minus 3x here and 2 minus 2 here. So we left with 3h. Positive 3h. So we have 3h over h. And then this h can be cancelled out. So we left with 3. So limit of a constant 3. This is limit of a constant 3 as h approaches to 0. So for a constant directly, we get the same answer, constant, which is equal to 3. Okay? So next example B. fx equal to 5 minus 2x. So the first step, always the first step we need to do is find the f of x plus h. So it will be f of x plus h equal to 5 minus 2 of x plus h. We replace the x as x plus h. And then simplify it, we get 5 minus 2x minus 2h. And then substitute what we have here into the formula. So what we have is limit of 5 minus 2x minus 2h minus 5 minus 2x. Okay. So kalau saya, first step saya tak akan expand terus. What I will do, it will be limit of 5 minus 2x minus 2h minus 5 minus 2x. And let be in the form of minus fx as h approach to 0. Okay? After that, baru kita simplify. So what we have here, 5 minus 5 and then minus 2x plus 2x will be 0. So we left with negative 2h over h, which is h can be cancelled out. It will be limit of negative 2 as h approach to 0. So it will be the answer equal to negative 2, directly equal to negative 2 because it's limit of a constant. Simple, right? Okay, next. By using the first principle, find the first derivative of the following function. So for A, fx equal to 7x squared minus 3x. So we find the first thing is f of x plus h. Right? As the usual, f of x plus h is equal to, we replace the x as x plus h. So we have square there. And then we replace the second x here as x plus h. So simplify, expand everything. Expand, to simplify, we need to expand first. Okay, because we need to subtract with fx later. So after we simplify, what we do, we get, okay, here we don't simplify. So we can, after we substitute into the formula, we can simplify or you can directly simplify. So if I want to directly simplify, what I will get? Okay, I will get 7 of x squared plus 2xh plus h squared minus 3x minus 3h, which is equal to 7x squared plus 14xh plus 7h squared minus 3x minus 3h. So, after you expand here, what do we get? Here, we expand the x plus h squared. And then, we multiply by 7. So this is what we have for 7 of x plus h. We have for f of x plus h. And then what we have for 7x squared minus 3x, after we expand by the negative sign here, we have minus 7 plus 3x. Okay, So now we can cancel out lah. Which one we can cancel out? We cancel out. So 7x squared with negative 7x squared. Negative 3x with plus 3x. So what's left here is 14. Okay. What's left? What's left? What's left here? So let's see together. What's left here is 14xh plus 7h square minus 3h. So if you notice here, every terms here we have h, right? We have h here, we have h here, means that we can factorize out the h. So let's factorize out the h. So we get 14x plus 7h minus 3. So this x also can be cancelled out. So what's left is 14x plus 7h minus 3. So if we write down, it will be limit of 14x plus 7h minus 3 as h approaches to 0. So to find the limit, what we need to do? We just replace the h by 0. Okay, so we have h approach to 0, means that this h will be 0. So actually this one just skip. So actually we need to write down, it will be 14x plus 7 of 0 minus 3. This one will be 0. So directly we get the answer 14x minus 3. Okay, so please copy the additional step here because it will help you understand why we have that. Okay, this one will be 0 here. Okay, so question B. Fx equal to ax squared plus bx plus c. Now we have a unknown for everything. So don't worry, it's simple. So to find the first principle, the derivative by using the first principle, what is the formula? We have f of x plus h. So we find the f of x plus h first, the first step. And then means that we have to replace the x here by x plus h. So it will be a multiplied by x plus h square plus b multiplied by x plus h plus c. And then usually I will expand directly here. What I will get, it will be ax square plus 2axh square axh and then plus ah square and then plus bx plus bh plus c. Okay, I will expand simpler because directly you want to put everything inside the formula and then you want to expand, you will have to write down many things at once. Okay, so that's why I like to expand first. But now we just look at this method. So they directly put the f of x plus h and then minus with fx, which is ax squared plus bx plus c, and then divide by h. Now after they expand, we have ax squared can be cancelled out with minus ax squared here, and then bx can be subtracted with bx, and then c minus c. So we left with 2axh plus ah square plus bh. So we have three things here: 2axh, ah square, bh, and everything here has h as the common factor. So you can factorize out the h. Okay, so after we factorize h, what left in the bracket will be 2ax plus ah plus b divided by h. And this h can be cancelled out. So we left with, limit of 2ax plus ah plus b as h approach to 0. So to find the limit, usually what we do, we just substitute, right? So substitute h equal to 0, we get 2ax plus a multiplied by 0 plus b, which is equal to 2ax plus b. Okay, really simple, right? Okay, so next example. Okay, no example, but exercises. Okay, now you guys can try to do on your own. By using the first principle, find the first derivative of the following function. So we have fx equal to x over 2 plus 5. And then y equal to 3x squared minus 7. And here is gx equal to 3 minus 2x all squared. So to find the derivative, we can represent it as what? Okay, it will be f prime x here because we have fx, or you can write down as d of fx respect to x. Here for y, it can be y prime or dy dx. And for gx here, it should be g prime x, or you can also use d dx of gx. Okay, so please use the correct notation. Okay, correct notation here. If not, then you will have your mark deducted. Okay, so this exercise you can try to do on your own to make sure that you understand the concept itself. Okay, so you can ask the answer, or I will give the answer later. Okay, thank you guys. That's all for this lecture. Bye.